Hello, today we're going to be talking about inverse trig functions. So this section might be kind of tricky for a lot of you. So be ready to pause the video and make sure that you understand what's going on before you move on. So when I say inverse, if we had something like 4x equals 16, right now we're multiplying 4 times x. The inverse operation of multiplication is dividing. So you guys do inverse operations all the time, you just might not know what it's called. So the opposite or the inverse of multiplication is division. So I divide both sides by 4, and I get x equals 4. So we're going to be doing the same thing, but with trig functions. So when I have sine, for example, if I have sine and I want to do the inverse of sine, that would be sine to the negative 1. So if you see sine to the negative 1, it's not an exponent. It's just the inverse or the opposite of sine. And then cosine of negative 1 is the inverse of cosine. Tangent of negative 1 is the inverse of tangent. So we use these inverses when we need to find the measure of an angle. So in the previous sections, they gave us the angle measures, and then we used those. We took like the sine of 30 degrees or whatever, and then we found the missing side length. So the way this works is let me use this down here as an example. So if this didn't say 30 right here, let's just say this said x. So we had sine of x equals 0.5, and we need to figure out what x is. So to figure out what x is, I got to get x by itself. So I would take the inverse sine of sine 30. So I basically take the inverse sine of both sides. Oops, that's not 0.05, 0.5. Can't find my eraser. There it is. So the sine inverse of a sine, those cancel each other out. So now I'm just left with, this should say x. Now I'm just left with x. Sine inverse of 0.5. So if you enter that into your calculator, to put these in your calculator, you're going to have to use the second button, and then the inverse functions show up. So sine inverse, oops. First you got to type in the number. So 0.5, sine inverse, and that's 30. So x would equal 30, which they tell us down here. So it's 30 degrees. So in example 1, if I'm trying to figure out the sine A equals 0.76. I'm trying to solve for A. I would take the inverse sine of sine A, inverse sine of 0.76. So inverse sine of sine cancel each other out. So I'm left with A is equal to inverse sine of 0.76. So on your calculator, 0.76 inverse sine, and you should get 49.46. So 49.46 degrees. Cosine of B. So to get rid of this cosine, I'm just trying to get B by itself. I take the inverse of cosine B and the inverse of the opposite side, 0.17. Cosine and cosine inverse cancel each other out. So I'm left with B equals cosine inverse of 0.17. So if you're using an iPhone, you got to type in 0.17 first, and then inverse cosine, and you should get 80.21. And this is degrees because, again, we're finding angle measure, so it should be in degrees. So now example 2, we got to use our calculator to approximate the measure of angle A to the nearest tenth. So I'm looking at angle A. So I have to figure out what two sides they gave us. So this side would be the hypotenuse because it's opposite of the 90-degree angle, so these are the two legs. So they gave us the two legs, so hopefully that'll tell you that you need to use tangent. So if I'm looking at angle A, opposite leg is 15, adjacent leg is 20. So the tangent of A is equal to the opposite over adjacent, so 15 over 20. If you want to reduce that, you could, so that would be 3 over 4. So now I have tangent of A equals 3 over 4. So I'm trying to solve for A. So I got to get A by itself. How do I get rid of a tangent? Well, I'm going to take the inverse tan of both sides. So inverse tan of tan, cancel each other out, they're inverses. So now we're left with just A on the left side. On the right side, we now have inverse tan of 3 over 4, it's 0.75. So I type in 3 divided by 4, 0.75, and then I take the inverse tan, and you should get 36.87 or so. That's not a 6. 36.87 degrees. In example 3, what is the measure of angle x? Oh, they did say nearest tenth, but I just did 100th. What is the measure of angle x to the nearest degree? So angle x is down here. They give us these two sides right here. So this side is opposite of the 90-degree angle, so this is the hypotenuse. This side is a leg, and this is a leg. So this leg is next to the angle, or touching the angle, so that's adjacent. This would be the opposite leg. So they give us the adjacent and the hypotenuse. So if you think of SOHCAHTOA, which one uses an A and an H? That would be cosine or ka. So the cosine of x equals the adjacent divided by the hypotenuse. So 13 divided by 18. So we are trying to solve for x. So I got to get rid of this tangent. Cosine. So to get rid of cosine, take the inverse cosine of both sides. Cosine inverse and cosine cancel each other out. So I'm left with just x on the left side, which is what I want. And then on the right side, I have inverse cosine of 13 over 18. So this is just something I put in the calculator. So 13 divided by 18. Oops, wrong number. And then inverse cosine. So I get 43.76. They told us to the nearest degree, so that would be 44 degrees. On the next page, what is the measure of angle Z to the nearest degree? So I recommend pausing the video and trying to do this on your own if you can. So the measure of angle Z. So again, we got to know which two sides they give us. So this is the hypotenuse. These are the two legs. So angle Z is this angle. It is next to or touching this leg. So this is the adjacent leg, and this is the opposite leg. So we are given the opposite leg and the hypotenuse. So O and H. So which one uses O and H? So SOHCAHTOA. That'd be so, S-O-H. So that's sine of Z equals the opposite over the hypotenuse. So 13 over 18. So I'm trying to solve for Z. So I need to get rid of the sine. So to get rid of the sine, take the inverse sine of both sides. So sine inverse and sine cancel each other out. So on the left side, I'm left with just Z. On the right side, I have inverse sine of 13 over 18. I think that's what we just did. So 46.24, but it says to the nearest degree. So Z would be 46 degrees. Moving on to example 5. A ladder is leaning against the side of a house, so it helps to draw the buildings. So this is my house. There's a little door. And then here's the ladder. So it says the ladder is 7 feet away from the house. So this distance right here is 7. This is a 90-degree angle, because the house and the ground make a 90-degree angle, hopefully. The height of the ladder is 15 feet. So the length of the ladder is 15 feet. What is the angle at which the ladder is leaning? I should say leaning, not learning. So we're trying to figure out the angle at which the ladder is leaning. So this angle right here. So I know this is the hypotenuse because it's opposite of the 90-degree angle. These two are the legs. So this leg over here is opposite because it's not touching this angle. 7 right here is the adjacent angle because it is touching, or it's next to this angle. So what trig function are we going to use? We know the adjacent and the hypotenuse, so A and H. So you got to think SOHCAHTOA. C uses A and H, so cosine, I'm just going to call this x, of x equals the adjacent over hypotenuse. So the adjacent over hypotenuse, that'd be 7 over 15. So I need to get rid of cosine and just have x there. So the opposite of cosine is inverse cosine. So I'm going to take the inverse cosine of both sides. Cosine and cosine inverse cancel each other out because they're inverses. So I'm just left with x on the left side. On the right side, we have cosine, or inverse cosine, excuse me, of 7 over 15. So 7 divided by 15, and then inverse cosine. Oops. Oh, oops. There we go. So you should get about 62.18. So that's the angle at which the ladder is leaning. At what height does it reach the house? So now we got to figure out this third side. So there's a few different ways we could do that. Let's use a different color here. Let's use blue. So we could use the Pythagorean theorem to find the side. We could use some trig functions. So let's call this side y. So I'm just going to use trig functions since we've been using trig functions. So if I'm using this angle, which I now know is 62.18, if I'm trying to find y, I could, this is the opposite side, opposite leg. So I could either use OH or OA. So it's up to you. So I'll just use tangent and use the O and the A, opposite and adjacent. So tangent of the angle, so the angle is 62.18, equals the opposite, so y, divided by the adjacent, 7. You could have also used sine, and you would have had sine of this equals y over 15. And you get the same answer. So now I need to get y by itself. So right now I'm dividing y by 7. So the opposite of dividing by 7 is multiplying by 7. So I'm going to multiply both sides by 7. So I don't know how to do that. So now I have 7 times tangent of 62.18 equals y. So 62.18 tangent times 7. So I get y is equal to about 13.27. I think it was feet, yeah. So 13.27 feet. And then the last example, so when we have a road at a grade of 7%, that means for every 100 feet sideways you go up or down 7. So what angle does the road make with the horizon? So we're trying to figure out this angle. So I got the adjacent and the hypotenuse. So that means I'm using cosine. So cosine of x, I'm going to call this x, equals the adjacent. Oh, whoops, I do not have the hypotenuse. Sorry, that was my mistake. I'm trying to go too fast because I know I'm getting kind of long in this video here. Can't find the eraser. There it is. This is the opposite side. I apologize. So if we have the adjacent and the opposite, that's tangent. And tangent is opposite over adjacent, so 7 over 100. So I take the inverse tan of both sides. So x is going to equal the inverse tan of 7 over 100. And you should get about 4.004.